defined. We defined the square root of -1 as I. So this now has a solution. And we wouldn't write an answer as no real solutions anymore. This is a true statement. There are not any real solutions to that equation. There are solutions. And now that we have defined the square root of -1 as I, we can write those solutions. The solutions are positive or negative I. Okay, now you try to solve number 2. Okay, so you got to here, and you wrote plus or minus square root of -9. Well, -9, isn't that 9 times -1?
Yes.
And the square root of 9 we know is 3. And the square root of -1 we just defined as I. So this is pretty simple to solve. It's positive or negative 3I. Okay, now last period started asking lots of questions. Where is this going? One of them said, will this affect how we factor?
Oh no.
And I said, yes, it will.
I said no.
Yeah.
You know? Because up until now, we have only factored over the set of integers.
Let's keep it that way.
But we just opened up a whole new world.
Let's close it.
All right. So,
I never looked back into the box into their phone.
okay, isn't that cool? Somebody said, are we studying solar systems last period? I said, no. This is my little rudimentary, thank you, Venn diagram. Okay? And so we're gonna take a visit back into the history of our number systems. What did we learn? When did we learn it? What do we know? Okay, so back in kindergarten, what was our first number system when our parents taught us to count? Okay, so those are our counting numbers, also known as our natural numbers. And we've talked about this year already, haven't we? Then we added 0 to that because we needed something to represent how much we had left when our older brother stole everything.
Oh, yeah.
So we had nothing.
I don't have the older brother.
Younger. There you go. All right. So those were our whole numbers. So 0. That's how we represent that. Okay. Now, then in elementary school, you added some real numbers. We really specifically started with the rational ones. So that includes our decimal numbers, right? Our fractions, anything that can be written as a fraction. Okay, and then probably early 6th grade, maybe late 5th grade, we added in integers. Integers. So we looked at the positives and the negatives. ... -3, -2, -1, 1, ... Okay. And then, sometime during middle school, you started measuring distances around circular objects. And what did we introduce?
Pi.
Pi. And pi is what kind of number?
Irrational.
Irrational, you are correct. Okay, so other numbers fit in here. Pi fits, square roots we don't know, like square root of 2.
I.
I doesn't. I's going to live out here because it's not real. But another letter does, E. E. I'm so glad you asked because next month we're going to study E. I will satisfy that curiosity. All right, now, today we just learned about a new number that we know is not real. So it can't live in the real bubble. Okay? It's imaginary.
It's in my head. So it's not, this isn't real.
Could you call it?
Imaginary numbers do exist.
What?
They exist. You can't count them. They're not natural numbers. They're not accounting numbers. Okay?
2 and
Alright,
negative square root of
so-
15.
So once again, I represents that imaginary unit. Alright, now, you see that all of this is living inside of one more bubble.
I know, I think it is.
All numbers.
Okay?
That's pretty.
So when we put everything together, when we try to mix up the real number part and the imaginary part, it gets a little complex.
It's called complex numbers.
That's called complex numbers.
You were so close.
I was gonna struggle to see.
Yeah, concrete, because they're really close. Complex concrete.
It's not
That's not close at all.
Alright, so complex. Now, complex numbers have a real part and an imaginary part. Real, we represent with the letter A. Imaginary, we represent with the letter B.
I.
Okay?
This would be I.
I. That's I. I for imaginary.
But you said B represents imaginary.
Like we could have 1 imaginary, 2I, 3I, negative 6I, square root of 2 I's.
This is not. I don't like this.
Alright? So,
Anyone.
this is the totality of the number systems. Okay? Well, everything we learn fits in this big bubble. This contains it all.
Is there anything, well, no.
Okay, now we can define more specifically some things that live within this bubble,
What about that time?
like this. Okay? But the definitions that you need to know we've already talked about. So I'm not going to ask you about transcendental numbers. Algebraic numbers are just numbers that are a result of solving something algebraically. So,
That would just spit out.
so you ought to recognize this, natural numbers, and when you put the natural number with 0, what's your number set right here? Not names, just the whole numbers. And then integers, rational, you don't have to do real algebraic versus algebraic, and real. Now, irrational does lie within the real number system. So it's not showing up by itself on here. So across the horizontal axis, we have our real numbers. Up the vertical axis, you have your imaginary. And together, they all make the complex number system.
I like your graph better.
Yeah, it's, like I said, mine's a little rudimentary.
It doesn't even have lies outside of that.
Huh?
Please define.
Basic. Right. Okay, so today we're going to learn how to simplify radicals. We're going to learn how to do some addition and subtraction. We're going to talk about complex conjugates. And all of what we learn today leads us to tomorrow. We're going to build a little bit every day. So you leave today, this is easy. I want everybody to leave today going, this is easy. All right, it is brand new though. And sometimes it's kind of bizarre that we've been hiding this whole number system from you for a long time.
Yeah.
And the reason we have is because your brain wasn't able to understand it until now.
I'm pretty sure I understood square roots. I don't really
Yeah.
I don't know.
I have found myself trying to teach my son things before his brain is developmentally ready for it. Now,
I do that with my family all the time. Like I'll be sitting like with my younger like cousins and stuff, and I'll be telling them about stuff like, and then I'll be
they're not ready for it.
yeah. But the crazy, I was ready for that when they were when I was their age.
Different people do that. Mature differently. Alright, so guys, this is how we're going to think of it. Negative 36 is 36 times negative 1. So the square root of 36 is 6. The square root of negative 1 is I. Now, if if I presented you with this problem to solve, we wouldn't just get 6i. When you are solving, you always get plus or minus. But if the radical's already there, it's already signed for you. So it's positive, understood positive. So our answer is only understood positive. Versus this would be plus or minus 6i. Do you see the difference? Okay. All right, so how would we break this up?
4 or 5.
We know it's 20 times negative 1. But you are so right. That 20 can break down further to 4 times 5.
So is it the plus
So,
and minus 2?
The square root of 4 we know is 2. So if we can take the square root, we can bring it out from under the radical. The square root of negative 1 is defined as I, the imaginary unit.
And then root negative 5. Or
5,
negative 5.
yes, positive 5 is what's
Okay.
remaining under the root.
Do you have to multiply by negative 1? Because I did like 4 times negative 5 because that equaled negative 20. So I just pulled out the 2.
If you get 2i root 5 as your answer, then you know what you're doing.
Yeah, but I just got 2 roots of 5 because it was still a negative under the radical. So I just,
We
I
will
put
never
negative 5.
leave a negative under the radical.
Not even in this situation.
turned into I.
The negative under the radical becomes I. And we do not leave I under the radical because that means something different. That is a square root of negative 1, which is the fourth root of negative 1, which is different. Okay. This we would break down into 7 times negative 1,
Which is plus or minus 7.
which is I root 7.
What was that?
No one's real sure.
Oh, I know that. Can I do the next one?
Sure.
Okay, so, well, okay, I'm just gonna break it down even further.
I got an error.
Okay, so you can have, I'll do the square root, 25 is 16, and then times negative 1.
Okay.
And then after that, it'll be, you could, well, you could take out 5/4,
That's right.
and then it will be I.
That's right.
Yeah, that's it. So
That's
it's
it.
5/4 I.
He nailed it.
Don't you nail it to the ground.
All right. Any questions about simplifying radicals?
Do it.
Okay. Now, we're also going to talk today about a complex conjugate. Now, complex form, we already said, was A plus BI form, where A represents the real part and B represents the imaginary part. So in this complex number, 2 plus 3i, 2 is the real part, 3i is the imaginary. Negative 4 is the real, negative I is the imaginary. 0 is the real. Do you guys see that there is no real part?
Yes.
So it's 0 is the real. Negative 7i is the imaginary part. And this one, it is only real. 6 is real. So there is no imaginary part. Alright, now, to do a complex conjugate, you negate the imaginary part. Very simple. So if we negate the imaginary part, if it was positive, it is now negative. If it was negative, it is now positive. Now, do you see how I did not touch the sign of the real part?
Yeah.
Okay? So, here's the imaginary part. Its conjugate would be positive 7i. Very good. Here's,
Negative 6.
it's
Or
Just 6.
it's just
Don't
6.
change
It's-
the A.
Okay, I get it.
Okay?
I'm a little brother. Okay, didn't
Alright.
Alright. He's 10.
Okay, now, last class, this was not enough for them. They're like, conjugate, why? Why? Why?
Why am I doing this?
Okay, and I said, this is why. And then I said, think about it.
Ooh, have you seen that in the
What does I represent? A negative square root of negative 1. In this form, if I represents the square root of something, am I allowed to leave it in the denominator?
No.
No. So how do I move it?
Times.
How do I get rid of it?
Times I.
That's where the conjugate comes into play.
Oh.
Okay? And we're going to look at that tomorrow.
Okay, good, tomorrow.
All right. So, well, today we were supposed to work through the workbook, but I didn't tell you to bring it. So here are the problems from the workbook.
Got it.
All right. Okay, this is geometry workbook.
I don't
Yeah.
I do.
It's my fault.
I think, yeah.
And all that's because the state of Georgia moved around my standards.
For sure, I definitely did not.
Aren't they awesome?
You only
I like your text.
I'm gonna need pictures.
Alright, give it a try. Okay, so all you're doing is on 1 through 8 is you're drawing this bin.
Is this homework?
Does it live in the real bubble? Does it live in the imaginary bubble? Or does it live in the complex box? Now, does everybody notice, and let this sink in, do you see that the real part and the imaginary part both live in the complex box? Because what is the complex number made up of? A real part and an imaginary part. That's why they have to live in the box. Alright, try that.
Why you can't just write the square root of -1 like that?
You're welcome.
Yo.
Isn't that like later on? Why can't you start at the beginning?
No, it's just how we have to find the square root of -1 as I.
Okay, got it.
Yeah, I'm so, my ribs are eating, they have to be.
Oh,
I'm having so much fun.
Good.
We played 2 games.
Where do you play tonight?
I don't play night, I play Friday.
We're gonna play Saturday. Where is the Friday?
Friday, I play at Riverdale, we play here in this Griffin.
Saturdays?
Yes, but it's against Griffin.
Yeah, but
Are
they're
they
reasonable.
good?
Are these pages on the living world that we don't finish? Actually,
That's not a Venn diagram.
Black people.
It's just 2 circles.
It's actually an ellipse.
It really
There's
is.
these are
Go to
Griffin
ellipses.
cheetahs.
Ellipsi,
Okay.
ellipsis, same thing.
It's a bin.
The definition of a Venn is
But
that
bins
both
overlap.
overlapping. Yeah.
They don't
She's
have
a
to
math
overlap.
person. She's not a English
You're
person.
not that
She doesn't earn a dictionary.
I'm gonna
They,
trust you on this.
they do not have to overlap.
So, 8 would just be
Maybe it's still
5.
unfamiliar with.
I can't
It's a
read
real
real.
It's not real.
I'm a
It's
real
not.
boy.
They don't like real. It doesn't like. Can't stop
It
it.
doesn't live in the real world.
It's okay.
Everything stupid. But it's just. It's like a good quality.
Yeah. TDEF was like the center. Yeah, it's like it was a
Oh,
yearly, separate before your exam. Program.
Okay, so the numbers for us to separate the equation into the numbers.
This is complex, so it's in the box. It can't go in.
No, separate the equation.
Alright, so number 1 is complex.
Oh, I didn't
Because it has a real part and imaginary part, so it lives in the box.
Oh, I didn't even.
Number 2 is a real number. So it lives within the real number bubble. Number 3 is irrational. Guys, I really worry about some of you. You should. Because you spend a lot of time talking. A lot. Expect the amount of talking and your grade to have an inverse relationship. All right, number 4 is just imaginary. Number 5 is complex. It has a real part and an imaginary part. Number 6 is just real. Number 7 is also real. And number 8 simplifies to -5i,
Oh.
doesn't it?
Oh.
So this should live in the imaginary world. Now, please note that all the real numbers and all the imaginary numbers actually fall under the umbrella of the complex numbers, right? They are complex. They just only have one part or the other. All right, conjugate. So conjugate, all we do is negate the imaginary part. Please try.
all of it.
What's up, child?
Wait,
Imaginary.
The one that's next to the eye, buddy.
Okay, as soon as you finish 17 through 22, give those a quick check, see if you have any questions.
Wow.
Alright. And then, we're not going to do these. And then let's see if we can simplify 1, 2, and 3 here. See if you can simplify those.
Let's say 71.
76 and 77. All right, how'd you do on 1, 2, and 3? Good, good.
I'm actually surprised you got that.
This is actually surprisingly easy.
Yeah, I was
Good,
like,
good, good.
question.
All right. So, the last thing we're going to look at is some simple operations with complex numbers. So today we're just going to begin with addition and subtraction. Okay? So, you guys know how to do this without me telling you what to do. What's the answer to number 1?
6 plus or minus 2.
Very good. That's exactly what you do. You add real parts with real parts, imaginary with imaginary. Write your answer in A plus BI form of a complex number. Perfect.
If you multiply I by I, do you get 1?
I was gonna say I squared.
But I like it. If I represents the square root of -1,
You squared a negative 1.
and you do I times I, isn't that I squared?
Oh my.
Squared?
We're going to negative 1.
Yeah.
Oh.
Alright, and that's just a little preview of the fun things yet to come. Alright, so number 6. Subtraction is just subtraction, guys. You have to distribute the negative, so we would change, 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 and then add like terms.
So 9.
So add the real with the real, and the imaginary. Oh, hold on, real with real. There's no real other than -2. Imaginary with imaginary.
God.
Yes.
This isn't bad right now.
Okay? So you try 1 through 4.
Okay.
I think if you can do 1 through 4, we're probably good.
Standard number B will where real numbers come before imaginary.
Standard form is the A plus BI form for complex
Oh,
number. So
yeah.
it's real first and then imaginary, yes.
You shall not pass. It's not mine, it's just yours. Oh, yeah, I'm stupid.
Oh. All right, how do your 1 through 4 look? Okay, let's do 9, 10, and 11 together. So this is addition. So negative 1 and 6 makes 5. And then positive 2 and negative 9 makes negative 7. Okay, we're going to change. And so here we get negative 1 and negative 10. And here what would we get?
7 plus 10i, or
Negative 7 plus 10i. Okay, so addition and subtraction are really quite simple. Okay, so your homework is out of your geometry book, which we've already discussed the little issue with that, just the fact that I've collected most of your geometry books. So, because I did that, I printed out the problems for you.
Oh.